Hello everybody, welcome to my channel. I have been making videos since 2019 when I was in class 11th. The initial videos are pretty much of bad quality, but kindly also have a look at those videos. Now, in today's class we shall discuss what is air pressure. So first of all, what is pressure? Pressure is the force exerted by an object towards the other object. It's called pressure. In the geographical terms, pressure does not have any different context, but in the terms of air, this is land, earth, surface. This is incoming solar radiation. This is incoming solar radiation. Here, cold air is located there, and when solar radiation comes, then this cold air becomes warm and it moves upward. This thus creating a low pressure area in this zone. So, why this air moves upward and this upward movement of air is called upwelling. This is the technical term, upwelling of air, which causes low pressure zone, low pressure zone it creates. Why this air moves upward? In physics, we have seen that there are three states of an object. That is solid, liquid, and the gas. The molecules of the solid object are compact. Whereas the molecules of liquid object are free to some extent, but not as compact as solid object. On the other hand, the gas and apostrophe s, gas, I'm saying that gas and the apostrophe, gas molecules are free to a greater extent than liquid and solid. Solid substances have greater density is high, and gas density is low. From this we can infer that those substances whose molecules are compact are highly dense, and those substances whose molecules are pretty free, they are scattered, they are freely moving here and there, their density is low. And when we heats an object, when we apply heat to object, heat is applied by a source, maybe it's a burner here. So the molecules of the solid starts moving very fast here and there. This causes melting of solid and it converts into liquid, and that's called lava. In the volcano, or the magma. The difference between magma and lava I shall discuss in future. So the liquid has lesser density than solid. So solid converts into liquid, which implies that its density decreases. So when we apply heat to any substance or on an object, their density decreases. That's the first point I have discussed. And as we know, the heavy objects like a stone falls on the ground. When we throw it, then it automatically falls on the ground due to the force of gravity. But the balloon is filled with helium gas, floats in the atmosphere. Why is this so? Because solid substances or the stone have higher density, but the balloon has lesser density, which implies that in geography, substances which have high density which remain at the lower horizon, but those substances which have or which will have higher densities will remain on the higher horizon. That's the one point. So 2 points we have inferred from here. Now when solar radiation comes to us towards Earth, this is solar radiation. Incoming solar radiation comes to the Earth's surface. Then it heats the air around a nearby land. This causes the molecules of air to further move, which causes decrease in their density, and lighter density substances remains at higher horizons. As a result, air with lower density will move upwards. As a result, low pressure will be created here. So those regions which have high pressure, from those regions the winds will come to that the low pressure region to fill this gap. So this is the low pressure region that I have explained. Similarly, high pressure is also created. How high pressure is created? For example, in polar regions or around 65 or 60 to 65 degree north-south latitudes, downwelling of winds occurs. When downwelling of wind occurs, this creates higher pressure in the region. So this will create high pressure in the region, high pressure zones. The air pressure of any region is measured by an instrument which is called barometer. Barometer measures the air pressure, and the unit of air pressure is millibar. Now I shall discuss. So this was all about the high pressure zones, the low pressure zones. Now, what is barometer? It's an instrument to measure air pressure. Mercury is filled in it because mercury has very high melting point. When the readings of barometer increases considerably, drastically increases, that it indicates higher pressure. High pressure. So, pleasant, clean and pleasant weather will be found in the region. If you don't know the difference between weather and climate, then see my previous video. And if the readings of barometer falls drastically, then a low pressure region will be created. Low pressure region will be created. As a result, cyclones will be formed. And third is when the barometer increases and decreases alternatively, then it will lead to, or it shows that storm will occur with heavy rainfall. Storm with heavy rain will be there. So that was all about barometer. Now we shall discuss the distribution of air. How the air is distributed. We have two types of distributions of air. First is the vertical distribution and second is the horizontal distribution. Vertical distribution is pretty much easier than the horizontal distribution. Vertical distribution is nothing much more, nothing difficult. It's not much difficult because the concept of the vertical distribution is that those regions which have large amount of air will have higher density, and those regions higher air pressure, and those regions which don't have larger amount of air will have lower air pressure. For example, suppose this is 3000 meter high. And this is mean sea level. There are different columns in there. This is the first column, this is second column, this is fourth column, this is fourth column, this is fifth column. This is the column of air. Larger amount of air is found at lower altitude. So that is why high density will be found here. High air pressure will be found here. High pressure will be found here. Whereas as height increases, we can see the amount of air decreases and then decreases. At height of 300 meters, it is very small. So here low air pressure is found. By this we can conclude that as height increases, air pressure decreases. This is our conclusion. Hard and fast rule. This is simple vertical distribution of That's why when we go to higher altitudes, our skin become ready. If we are exposed to very low pressure region, then the blood from our body or our body's pressure will or won't not match with the outside atmosphere or the external pressure. So this leads to so our body's pressure will be very high and external pressure will be low, and as we know, high pressure substance moves towards the low pressure substance. As a result, our blood will come out of our body. This will lead to bleeding in our body, hemorrhage it will cause. Now I shall discuss the horizontal distribution of air, after which I shall discuss the different tricellular model. I shall discuss in the next video, because there is paucity of time. Paucity of time, in fact, is there in this world also. Everybody is striving to get success in their life, and so I do. Now, air pressure, horizontal distribution of air pressure. Horizontal distribution of air pressure. There had been some unforeseen causes there, so that I have to stop the video. Now, this is the horizontal distribution that we were discussing of air. Now, our Earth's air pressure is divided into 4 parts. First is the tropical pressure zone. Different zones are divided in particular. I shall draw the map of, or I shall draw the globe. This is Earth. Zero-degree equator. (10° north, 10° south latitudes). 35° north, 35° south latitudes. 65° north, 65° south latitudes. 90° north polar region, 90° south polar region. From 10° north to 10° south, this region is called tropical pressure belt. From 10° north to 35° north and 10° south to 35° south, this is called subtropical belt. From 65° north to 35° north to 65° north and 35° south to 65° south, 65° south is called subpolar belt. Polar belt. Subpolar belt is also called temperate zone. Temperate zone. 65 to 90° is called polar belt. Now, our equator, 0° latitude, receives sun rays throughout the year, constantly receives sun rays throughout the year. And solar radiation is perpendicular throughout the year between 20 and a half degree north to 23 and a half degree south. So the equatorial region have received very large amount of solar radiation. This causes very low pressure in this region, because when solar radiation will be high, then air will move upward, thus creating low pressure in this region. That is why upwelling of winds occurs here. At a certain height, winds diverge in the left direction and the right direction because of Coriolis force. Coriolis force is Coriolis force, or we can say Coriolis effect. Coriolis force is in effect there. Because of Coriolis force, solar radiation, winds are deflected rightwards and leftwards at a certain height from the equator. This creates a very low pressure zone in this region. This is called tropical pressure belt. This region receives very large amount of solar rainfall throughout the year. Daily afternoon rainfall occurs here. After that, it falls down at 35 degree north. The wind that has reached a certain height will get reflected, and after get deflection, their temperature will decrease. As a result, they will fall down, and thus creating a very high pressure at 35 degree north and south latitudes. And they will move leftward and rightwards. And here they will move towards equator, 0 degree latitude, and they will meet the upward moving winds, thus completing this cycle. This cycle that has been thus completed is called Hadley cycle. Hadley cycle. After that, here very low temperature is found. That's why winds are downwelling, and it will move towards like this, towards 65 degree north. And 65 degree north, the wind moving from the 35 degree north meets the winds moving from polar region at 65 degree north, and the warm wind moves upward. As a result, thus creating a very low pressure zone in this region. At a certain height, the wind will get deflected, and thus this wind will meet polar winds, and this wind will meet the wind at 35 degree north. So this is a horizontal distribution of air. Horizontal distribution of air pressure. Between 10 degree north to 10 degree south, low pressure will be found, and between 10 degree north to 10 degree north to 35 degree north, and 10 degree south to 35 degree south, high pressure will be found. And 35 degree north to 65 degree north and 35 degree south to 65 degree south, higher pressure will be found. And low pressure will be found particularly at 0 degree in the regions around the 0 degree. And high pressure will be found in the regions particularly around 35 degree north and 35 degree south. And the low pressure will be found in the regions around 65 degree north and the 65 degree south regions. The wind that moves from 35 degree north towards 0 degree is called trade winds. This wind is called trade wind, that moves from 35 degree north to 0 degree. And the wind that moves from 35 degree to 65 degree is called westerlies. westerlies winds. And the wind that moves from polar region to 65 degree north, 90 degree north to 65 degree north is called polar easterlies winds. Easterlies winds. The movement of these winds are like that. I am giving a brief of these winds because I have to discuss these winds later in the later classes. Movement of wind will be like that. Trade winds. These will be trade winds. These will be westerlies winds, and will be 35 degrees south to 65 degrees south. Leftward shift over. These will be westerlies wind and polar winds will be like that. So this is all about the air pressure. In the next chapter, we shall discuss different types of winds like permanent wind, local wind, and I have given a fillip to you, fillip or impetus to you to know more about these winds. Now we shall discuss the topic in the next video. Thank you, and if you like this video, then kindly subscribe to my channel and like the video and share it. Thank you.